Yeah. So tonight I want to walk you guys through what we've seen, or what I've seen over the past few years of how we do networking, how we connect our VPCs within AWS. This is not super low level. We're not going to go into what BGP is and how that affects what we do. This is at quite a high level and the services we use. And then I want to show you some of these things we do. How do we use a tool like Terraform to automate these environments and these networks? So a little bit about myself. My name is Paul. I work for a company called Synthesis. I'm a technical lead down here in Cape Town. That's my handle on kind of everything. So the code I'm going to show you guys tonight is on GitHub. Meetup AWS Network Evo. And a bit of my background is I study engineering. I'm an electronic engineer, and for quite a while I worked as a hardware developer. So we built weighing equipment for large weigh bridges. There I did quite a bit of electronic design and embedded development. I did desktop apps. We used desktop apps back then. I didn't know about cloud. And then I discovered like the IoT thing, which really fancied me. And that was my first foray into cloud. Back then, cloud was DigitalOcean for me. And I did some, we tracked cattle, like on the farm. We tracked cattle and we tracked their health. And that was a pretty cool intro to cloud computing for me. And then I did a few things in between, and then I ended up at Synthesis, and we're AWS partners. And I don't think today we actually have a single project at a client that's not somehow hosted in AWS or leverages of AWS in some way. One of the pet projects I'm involved is a thing called Genomia. And this is something like a bunch of friends said, yo, we're doing the same thing everywhere. From a security point of view within AWS, let's see if we can build a tool. And it uses Cloud Custodian in the background. And you guys are welcome to go and go to that link, sign up. It's free. And we're not trying to make money out of it, at least not for now. And break it. Please break it and let me know how you broke it. And then I've done a few AWS certs, and recently I did a Terraform cert as well. It just kind of comes with the territory when you're in AWS. So getting into networking, before you can fully understand how we do networking in AWS, it's quite important to know how, like I work in an enterprise environment, to know how enterprises structure their AWS environments. So there's a thing called the landing zone. A landing zone is just a concept. You can achieve a landing zone through rolling it yourself. We actually did that before. A landing zone was a thing that a service that AWS provided, or you can use something like control tower. But what it is it's a structure, a multi-account structure, where certain functions gets centralized and certain functions gets distributed. Functions that get centralized as things like security, as something that's usually within an enterprise. There's a central team looking after security. Networking is a central function. Logging is usually something that is centralized to a certain degree, and then there's shared services within your environment. And a landing zone gives enterprise a framework to do this in. And one of the key tenets of a landing zone is that app teams, like what we're going to end up being in that landing zone, you've got your own account, and within that account, you've got your own VPC. And that was quite exciting when we started with AWS and going on to this AWS journey with our big clients. Because traditionally, and if you've worked at many enterprises, they've got these massive networks, and every dev server can talk to every other dev server, and in many cases, a dev server can even talk to a prod server. And being able to give each dev team their own network was a very cool idea. and landing zone totally supported that. So from an enterprise point of view, that's how we build stuff. You've got a landing zone, and each app team has their own account. In that, they've got their own VPC, and they've actually got multiple accounts depending on all the SDLC stages that the company supports. So you could end up easily sitting with 100 VPCs in an environment, and yeah, actually we've got clients with way over 100 accounts, let alone VPCs. Okay, so that kind of sets the scene. You've got this environment, you've got a ton of little networks that need to chat to each other. And how do you achieve this? And like, what's the stages we went through to get to where we are today? So like VPC to VPC connectivity, there's two main models. There's like this many-to-many, this almost like a mesh network, and then there's like this hub and spoke environment. And the many-to-many is like this worst case that everyone talks about. And that, like, if you know a bit about network theory, you'll know there's this thing called Metcalfe's law, which states the complexity of a network is the number of nodes squared. So in a worst case scenario, every node needs to be connected to every other node. So every VPC needs to be connected to every other VPC. In reality, that doesn't really happen. You more commonly see like a central like VPC, or a VPC that serves a central purpose, and a lot of VPCs connect to that one. And then you've got here and there, you've got connectivity between VPCs. So that's for the almost like a peer-to-peer connection between VPCs. And then there's the hub and spoke, where you've got some central special type of thing, special VPC or special device that allows you to that orchestrates traffic between nodes. So these are the two modes you can work in. There's one that's kind of a hybrid of the two. We've got a few hubs with accounts around them, or nodes around them, and those hubs are connected. That's not something I've actually seen in the wild. I know you can obviously build networks like that, but from a VPC connectivity, like peer-to-peer or hub and spoke is basically the two models you can operate in. So if we look at what AWS gave us to facilitate VPC connectivity, like I initially thought VPCs was one of the first services that AWS rolled out, but it wasn't. People actually had to wait a while for it. So VPCs was introduced in 2009, and then a bunch of stuff happened in between. But in 2014, VPC Peering was the first big thing to come to facilitate comms between or connectivity between VPCs. 2015, we got VPC endpoints. Pretty cool stuff. Not really VPC to VPC comms at that point, but it allowed connectivity for your VPC to other stuff. VPC flow log's not really a connectivity thing, but if you've worked in AWS and you've built a network, you know, like this stuff is your friend. VPC flow logs is very important. NAT gateways was the next big thing. Before it, we had to use NAT instances, which helps you to get out to the internet. Egress only access to the internet. Then in 2017, we had VPC endpoint services like PrivateLink, a very cool service again, not connecting two VPCs explicitly to each other. You probably could do that, but more exposing services in different VPCs to each other. Awesome service. And then in 2018, a big thing happened, and that was transit gateway and VPC sharing. And from what we saw in the corporate world, or in the enterprise world, VPC sharing kind of flew under the radar, but transit gateway was a big change for us. So these were kind of the tools we had in our belt to say, like, how are we going to build networks within within AWS. So the first thing we did, and I think this is like ground zero for most people when you start building networks, is VPC peering. And full disclaimer, I haven't actually seen any enterprise use VPC peering, but we used it. So when we started, we built, like, we didn't have a on-premise network. You just have everything is in the cloud, and then VPC peering is awesome. VPC peering allows you to connect two VPCs to each other. It's got a few interesting things, like it doesn't cost anything. Like, you can connect two VPCs for free. You only pay for the traffic between them. Something that it misses, and this is like the big reason why you won't see it in an enterprise as the main network topology, is it doesn't support transitive peering or transitive routing, is meaning VPC A, VPC B, and VPC C is connected. A can't chat to C via B. It needs to establish its own connection, and that's where that mesh network comes in. And that's where it could theoretically get very messy if you have a lot of VPCs. VPC peering has very hard limits. I think I've got it in my notes here, 125 maximum connections per VPC. I don't think you'll ever actually reach that. The complexity of your network will get completely out of hand long before you hit that limit. And network degradation is a serious problem with VPC peering at that scale. So you feel it on your network. Individual peering connections doesn't have, so even though there's hard limits on that, individual peering connections doesn't have bandwidth limits. So you're restricted to the instances, like the ENIs, like the bandwidth they can handle, but the connection itself doesn't have a bandwidth limit, which is pretty cool. So you can do, like, if you have to do high bandwidth comms, VPC peering might be a good thing, or good way to get there. Then if you built a network around, like, you've got a bunch of VPCs, and now you have to connect that to external networks, either to your on-prem network, or you've got a third party that you want to connect to, and that network needs to be connected to more than one VPC. Because there's no peering, like, you would have to create that connection. You'd have to make that multiple times, and that's problematic. If it's something simple like another peering connection, that's okay. But if it's something like a VPN tunnel that needs a lot of configuration on your on-premise network side, like, that's tedious. You don't want to do that. So that's if you're connecting to external things, that's VPC peering kind of falls apart. It doesn't fall apart. It's maybe not the best option. And then something really cool that I liked about it is that I still like about it is the fact that you can start, like, referencing security groups from the other VPC. So I could, on my EC2, I could say, like, I trust this security group. I don't have to know the CIDR range that I'm trusting. It's just I trust the security group from that peered VPC, and AWS can actually resolve that and use that in security groups, which is quite nifty. Another thing that's pretty cool is that it's inter-region. So for the most part, we don't use multiple regions in enterprises, but with the South African region that's launched recently, that's becoming a thing for us now. So inter-region connectivity is quite important now, which it's supported. It didn't in the beginning. I think it only launched in 2017 or something like that. But today it does support it. So VPC peering, not something that we looked at as a global network for global network topology, but a very handy thing. Most recently, where I used it is with Confluent Cloud. You can connect to your instances using VPC peering. So, and when you use Kafka, the like you can have some serious bandwidth requirements, and that's where VPC peering is still relevant, even though that won't, like, you won't put your main network topology won't be driven by VPC peering. So that's quite, like, that's cool, and that's kind of where VPC connectivity started. Then we went into, like, we got serious and we had to solve for enterprise. The big requirement was you've got an on-premise network, you've got a cloud network, you have to connect these two, and you've got a ton of VPC. So we needed transitive routing. We couldn't have this mesh. And that's where a transit VPC comes in. And essentially what it is, it's a VPC that runs something like a FortiGate or a Palo Alto, or like pick a firewall device, and you connect using VPN connections to it. So this design could run from day one when VPCs was introduced, and it actually did. Like, this was one of the first patterns. Because it didn't rely on really AWS native things that much. So yeah, we used this. This solved, like, a lot of problems for us. Solved the transitive routing. A problem we had, though, is we're AWS people, and now we're introducing, like, this third-party appliance into the mix. We're not FortiGate experts. We're not Palo Alto. So that was one of the trade-offs that you made when you chose this. Is you kind of accept you have to bring a non-AWS person. I say non, you need, like, another specialized skill to run this. Like, we could totally spin it up, but maintaining a FortiGate is a specialized skill. So that brought that in, and then obviously there's costs. Like, this is a EC2 that you need to run. On that EC2, you need something that's usually licensed, so it could become quite a costly exercise. But it actually scaled quite well, because you could just, like, these firewalls are built to handle a lot of connections going to it. So the client I mentioned that had 100+ accounts, they were all connecting to a transit VPC, and we never had issues with this. It was a joy to work with it. To set it up was painful, but we never had downtime with it. Touch wood. It also had, like, because it's just a VPN connection, there's no region restrictions. If you can establish a VPN connection to it, no matter where, from third party, your own VPC, a VPC in a different region, so it's not region bound, which is it wasn't relevant for us really back then, but it's becoming more relevant. A big problem with this, though, was automation. Many of these appliances, they weren't built to just deploy and set up automatically. The vendors, like the FortiGates, over time they got better, and it became easier to automate some of the functions. But establishing a VPN connection is very hard to automate if you don't control both sides. So if that thing had to go down, and we wanted to spin one up quickly, creating that connectivity to the on-prem team, like, isn't something you could automate. That was a very manual process still. And then these HA, like, getting this thing highly available was hard. I spent a large amount of time just testing the HA for this thing, like in which cases, like, how does it break? How do we recover from it? And we never got full, like, automated failover and recovery. Like, that was quite hard to get that going. So though we had those challenges, other limitations of this, which we never ran into them, but is, like, those VPN connections have they also have quite hard limits on the bandwidth, on their bandwidth capabilities. but like I said, like we never ran into it. But obviously, if you have a high bandwidth requirements, you might see that as a problem. And then something that these appliances also brought to the table that was pretty cool was layer 7 security. So you could do packet inspection, intruder detection or prevention. So those are some of the benefits that this architecture brought companies. Like it had its drawbacks, but it worked very well. And there's today few clients going onto AWS that still uses it, even though there's alternatives like AWS native alternatives where they still choose this in scenarios where they are running, for example, Palo Altos on-prem in Azure, in GCP, and then they run them here and they can push the same policies across all the firewalls, which is like you can see why from a security and networking point of view, on-prem team, why that would be attractive. So this pattern isn't like dead. I kind of see this as a legacy pattern, but it is still being used. So next thing we say, okay, cool. This is quite common. So is like Transit Gateway came out, and this completely changed the game for us from a networking point of view, because this brought all that. All the knowledge became like you only had to have AWS knowledge to do stuff, and everything now had an API, which was awesome. So what Transit Gateway basically does is it's a router. It's nothing. It doesn't do anything fancy, but you can terminate VPN connections to it. You can attach VPCs to it, and like a direct connect, if you have one, can connect to that as well. Which means if you want to automate your entire environment, you don't actually have to, like I said, you just deal with AWS services. So for us, this was like automation heaven, because we could now do everything in code. So some of the cool stuff that came with it, there came like a ton of cool stuff with it, but it was HA by default, and I have a bit of an asterisk there. So your Transit Gateway is highly available. Your attachments to your VPCs isn't necessarily highly available. You have to attach it into subnets in multiple availability zones. But like for you guys working in AWS, is like we're almost always across multiple availability zones. So that's not really a problem. So it's kind of like HA by default. The bandwidth limits are increased. I don't actually know what the bandwidth limits are, but it's got increased bandwidth capabilities. Again, not really something that we are fussed about. It is, however, region bound, so you can't connect a VPC in Ireland to a Transit Gateway sitting in Cape Town. What you can do though is you can peer two Transit Gateways together. So I can have all my VPCs in one region connect to a Transit Gateway in that region, all my VPCs in another region, like in Ireland, connecting to my Ireland gateway, and I can peer those two. So that's kind of how they solve inter-region comms. There's also restrictions on the number of Transit Gateways in a region you can have. I think there's a limit on that. We don't really we spin up one in a region, and that's how that works for us. It doesn't do, like I said, it's a router. It doesn't do anything fancy. So that layer 7 or security you get from a transit VPC doesn't really translate to this. There isn't an equivalent. That's a big feature request we put in, that we want routing capabilities that's not just IP based. So the way you would route traffic is your transit gateway can have a default route table, which is like all peering connections it'll just route traffic to if a VPC A connects to it and VPC B connects it and they start sending traffic to the transit, it'll just route to all the propagated routes it knows about. We don't do that because you lose a lot of the granularity you get from being able to isolate networks from each other. So we create a route table per attachment, which you can totally do that. So each VPC coming into the transit has its own route table, and that's how you determine what it can route to. And then on the destination VPC's attachment, you need a route back to this one, which means we can have like very fine, I say fine grained, but fine grained to a subnet degree. Like that's as fine grained as you can go, and then we can determine where traffic can route, which is pretty, like, it's good enough. Like that's exactly what most clients use the transit VPCs for as well. This thing gets placed in the same as in that multi-account structure. There was a networking account, and that's usually where your transit VPC sat. The transit gateway lives there as well. And the way you only have one transit gateway. So and the way you use it with a multi-account environment is you actually use RAM, like Resource Access Manager, to share your transit gateway out to the accounts you want to connect. In that account, a VPC makes an attachment to that transit gateway, and depending on how your organization is set up, it will send back a request to your networking account to say, do you want to accept this VPC from being attached? So there's actions you have to take in two accounts to get a connection up. So that's how you would set it up. And then its billing is also quite interesting. So part of like in the enterprise world, there's chargeback. Like business units charge other business units for services, and chargeback was really, really hard with the transit VPC, because you've got this thing that's very expensive running in a networking account, and tracking who's using how much of it is hard. And breaking those costs down was quite tricky. And the transit gateway kind of solves that, because the transit gateway service itself doesn't cost anything. You pay for the attachments. So each attachment has a per hour charge and a cost for the traffic that goes over it. But that cost lives with the VPC. So if I'm in account A and I'm connecting to the networking account with my VPC, then the costs will actually reflect on my account. Obviously, in an organization, everything rolls up to the root account, and you see like a aggregated bill. But you can, when you break it down per account, you'll see that each account with an attachment. So the networking costs actually live in that account, which made chargeback really, really easy. That was always a big headache for us, like networking chargeback. The service isn't perfect though. You kind of fly blind when stuff goes into the transit. So if you've got quite a complicated network setup, and you mess up your route tables within your transit or within your VPC, it doesn't actually matter if your route tables are not correct, and you're debugging like, where is my traffic actually going? It can get quite hairy. So when I was learning to use Transit Gateway, I didn't say good things about it those first few nights where I was debugging it and can't figure out what I did wrong. So global networks are trying to solve this. I think it's Global Networks Service, where AWS maps out your entire network for you and can show you, like, you can kind of see, I can get from point A to point B, my route tables and my security groups and everything is correct. So it's still early days for that, but I think that'll solve it in the long run. But today, you'll like stuff going into the transit, it's a black box, and it can get quite tricky. So one of the first things I learned and I can't remember that I ever read it anywhere, was your attachment has a route from to say, I want for this CIDR range, go to that VPC attachment. I didn't know I had to put a route on that attachment's route table to point back to me. I thought it was like a stateful thing where it kept track of that connection, but it doesn't work like that. You need a route in that route table to get back, and that confused me quite a bit in the beginning. And like I said, like the route table per attachment is quite cool. I too often see guys like kind of being scared for the routing complexities you can run into, and then they just create one big route table. I would definitely recommend doing a route table per attachment. It's simple enough. Once you've wrapped your head around it, it's simple enough. So a pattern that I saw for the first time, maybe a month ago, was a hybrid between Transit Gateway and Transit VPC. I'm not this is a diagram out of AWS document. I'm not too comfortable with it, to be honest. I don't know how I feel about it. I haven't made up my mind yet. But the idea with this is to say that you can connect all your VPCs to a transit gateway, and you get a lot of automation out of it, and like out of the box you can connect it with minimal setup. Put it like this: connecting to a transit gateway is much easier than creating a VPN connection to a FortiGate. But then you spin up another VPC that runs those firewall appliances, and you route all traffic through them. And that thing actually is like the firewall is again a transit VPC. In this case, they use it. They call it an egress VPC, which like all corporate networks have, where it's a VPC that has URL filtering, has some sort of device that can use URL filtering. But in this case, they use it not only for egress to the internet, but egress is in this scenario seen as any traffic going out of your VPC. So in this example, for this VPC to chat to the one next to it, it'll actually go through the firewall device. And I don't know what they're trying to solve here. It's probably they're probably doing packet inspection and things like that. But this is quite a complex and an expensive network. So I'm still on the fence on this one. I'd like to see more clients exploring this, or hear more clients' arguments for why they're exploring this. Currently, I've just seen this at one client. So I'm still on the fence with this one. It kind of like feels like you don't get the best of both worlds. You get the worst of both worlds, and you pay for it. So if you see this, like, this is a thing. It's people are doing this. You can, but don't get worried. It's actually like it's really simple. It's still just a transit gateway, and it's still just a transit VPC. There's just a connection between the two, so it's not something from a networking point of view to get all worried about. It's a simple concept, but yeah, I don't know if it'll actually pay off in the long run. So now we've got transit gateway, and that's flipping awesome. Like, we automate everything, but there's like something they don't tell you in AWS school, and there's actually a cost to a VPC. So if you Google pricing of a VPC, you'll see the service is for free. You don't pay for it. But there is a non-direct cost. So VPCs are private, like it's in the name. But that means you have to establish connectivity to stuff. So I don't know when last any of you spun up a VPC that didn't talk out to anything. And it's just something that ran in that VPC. Everything it needed was just in that VPC. I don't know of many examples of that. So you have to create those connectivities. That connectivity to the world, and that connectivity to another VPC, to on-prem, to other AWS services. Like, that connectivity needs to be built. You don't just get it. And those things cost money. So that's the first thing. So having many VPCs, you have to do that many times. Then you lose IP addresses. So for each subnet, you lose 5 IP addresses. AWS reserves them. And initially I thought, like, this is a non-issue. Like, there's a lot of IPs out there. But in a corporate environment, it is actually a problem. Most enterprises have a limited number of private IPs they can use. They can add more ones. It's not impossible, but it's usually quite a process. So when we go into AWS with a client, usually the networking team gives you a subnet. It's a big one. It's like a /16. But that's all the IPs you have to use, or you have to your available to you in AWS. And if you use it up, or like you've created one big /16 VPC and you want to create a second VPC, it's a process. And sometimes it's impossible. Like we at a client, we got to a point where they said, there is no more IPs. You have to be smarter with your IP addresses. And 5 IPs per subnet. So in a simple scenario where you've got a VPC with 4 subnets. So you actually have 2 subnets across 2 availability zones, and now you want to connect it to a transit gateway or a VPN, a transit VPC, same thing. And maybe you've got a few VPC endpoints. That's 18 IPs gone. And that adds up, like over all your hundreds of VPCs, and that's a lot of IPs that's unusable. So that's one of the costs. I say costs, it doesn't actually cost you money, but it is a cost. And then, like, having VPCs there's management to them. It's like they generate flow logs. They can be entry points into your network. And you have to monitor this, and you have to do this across hundreds of VPCs potentially. So there's actual management cost to that. There's a person or a system that needs to be built to do that. And then VPC endpoints. I don't know how many people, like, that would be quite interesting to see of you guys who run your own AWS accounts. How many of you are actually using VPC endpoints? In a corporate environment, that's a very attractive thing, a VPC endpoint, where you get a direct link to an AWS service in your VPC, going over the AWS backbone. So, like you can imagine in a bank, the idea that your traffic doesn't have to leave the AWS network. It doesn't have to traverse the internet to get to a service like S3 or to the EC2 API is quite attractive. But these things aren't free, and those costs add up quite quickly. So when we started with AWS, we thought, like, it's not that bad, and the benefit you get from a security point of view is awesome. And we would roll out the common used VPC endpoints to all VPCs, and almost guaranteed 6 months down the line, the first cost optimization exercise you do is start taking away unused VPC endpoints, because they get expensive. So all these attachments and things to give connectivity to your VPC aren't free. So that's where we did kind of a reality check and said, okay, cool. Maybe having a network per workload, per app team is not the best way to go. It's like, it gave us a warm and fuzzy feeling in the beginning, but you have to be practical as well. So the architecture we're pushing today, and actually I say pushing, we're exploring it with the client now to see how viable it is, because it's still relatively new. There's not like when you chat to the AWS SAs, they say, yeah, we see this as being something that people want to use. but it's not something that's widely used. So we don't know what the shortcomings of all of the shortcomings is. So the idea is that we use VPC sharing. So what VPC sharing allows you to do is to set up a VPC in a central account, like in your networking account, and then take individual subnets and share that out to other accounts. And those accounts they see it as a VPC in that account, and they can provision resources into that VPC, into that subnet, without actually owning that VPC. And you can share that same subnet to multiple accounts. And guys, they're on the same network, so they're on the same VPC, but they can't see each other's resources. So the resource, like the EC2 instance, actually still lives within your account's boundary, but you're running on a shared network. So what we're trying to say is that maybe there's a middle way where we could, for VPCs that needs to be centralized, that needs, like, workloads that needs their own VPC, we still do that, but we provision it from the networking account, and we share it out to that account, to the account that needs it, and we attach that to a transit gateway. But for, like, if you think of a big corporate, where, if we think of almost every bank in South Africa, they've got a home loans department and they've got a vehicle finance. Maybe home loans have their own development network, and all their development workloads go into there, and vehicle finance has their own development network, and all their development workloads go into that. But these two need to chat to each other for whatever reason. They can still do that through the transit gateway. And being the same business unit, the risk of running these workloads on the same network is not it's not substantial. So that's the idea. And then like I said, for production workloads, you can decide all prod workloads going to the same network, or each prod network, or each prod workload gets its own network. Yep, I'm running out of English for today. So this simplifies your network completely. You really have a lot less going on in your network. All VPCs sit in this one account, which means even though I'm provisioning my EC2 in my own account, the ENI sits or is visible in the networking account. It also means my security group is visible in the networking account, which, from a networking and security point of view, having a view of all security groups in one place and all ENIs in one place is very attractive. It also means all VPC flow logs sit in one place. So, I mean, like, by default, we forward all of these logs to a central place in any case. But we don't have to build as much tooling now to get to that point, because everything is in one account already. So you can have this, like, centralized networking capability, but still have segregation where you need it, which is pretty nifty. Like, there's a massive cost reduction, and my gut feel is, like, the cost at the end of the day will actually be the same. The only difference is where we said VPC endpoints are maybe too expensive to roll out everywhere. We'll now start using more VPC endpoints in the VPCs, and the cost will be the same, but there's a massive security benefit from doing that. So if you don't introduce more VPC endpoints, you just have the same ones, then there's a massive cost benefit if you concatenate like 10 VPCs into one big one. Obviously, you don't have that problem where you lose a VPC. You don't lose all those IP addresses as well. That's another benefit. I mentioned centralized logging and monitoring. Pretty cool stuff. You do lose fine-grained routing options. So you don't have a transit gateway for workloads running within the same VPC. So if you wanted to to do fine-grained routing now, or I say fine-grained, it's not like the TGW can do crazy fine-grained routing. You'd have to rely on NACLs, and NACLs is something that we I don't say we avoid them as far as possible, but that for us that's a last resort, because NACLs, maintaining NACL rules can become quite tedious. So if you want that same type of granularity or routing restrictions, you would have to go to NACLs, where you could have just maintained a simple route table in your TGW. The loss of visibility for developers, like that's a bummer. And I'm pretty sure this is something AWS will fix. So when you share out a VPC and you share out a subnet, the tags on those things don't propagate down as well. So as a dev, I just see a VPC without a name. I just see subnets without names in there, which for me is a bit of a bummer. I would like to have seen that. And I also lose sight of VPC flow logs, because it's not in my account anymore, which probably for most devs, that's not a problem. But if you run into networking issues or weirdies, that's something you want. Then another cool benefit is you can start referencing security groups within the same VPC. So again, if my workload and Rian's workload is running in the same shared VPC, even though it's separate accounts, I can actually reference these security groups. And AWS will handle that for you. I'm going to show you how that works right now. So that's like the history, where we are, and this is where we are today. And this is all good and well, but how do we actually deploy these things? Like, it's quite hard. Like, you're deploying resources in multiple accounts, and that's where I want to show you. Actually, I wanted to build you like a full-out VPC sharing with Transit Gateway, and then life got in the way. So what I did end up is and it's on GitHub, how do you do this cross accounting in something like Terraform, and how do you share things across? Oh shoot, man, I'm losing myself. This is what the network now looks like. I couldn't get into the slide. So a Transit Gateway VPC sharing network you would have your networking account. And in your networking account, you've got your Transit Gateway, and here you can still attach your VPN or your production and non-production accounts. Each of them have their own route tables. Like in this scenario, my non-prod, I just black hole traffic that tries to go to production. It's like your dev environment shouldn't be chatting to your prod environment. So you can totally do that. In here, I've got subnets. I provision 2 subnets, and I share that out to app development accounts, and they get their own subnet, even though it's in the same VPC, and they can chat to each other. They can use that central egress point for that VPC without us as a central networking team having to worry that people go and provision stuff in a public subnet, which you can totally do with IAM. You can restrict where people deploy, like into which subnet you deploy stuff, but this just makes IAM so much easier as well, because I don't actually have to worry about someone deploying something into the public subnet, and they can use the same VPC endpoints for this VPC. So all the app teams, and there could be many subnets in here. So this is like what the architecture could look like. So looking at a bit of code, Rian, are we still good for time? I don't have it.
Yes, we're now on 7:51. So another 10-15 minutes. If you can maybe wrap it up before 15 minutes, that's perfect.
Awesome. Sorry, I get so excited about this stuff. So for you guys who are not familiar with Terraform, that's maybe a bit much.
Yes, thanks.
So let's go to VPC sharing. So you now have to provision stuff in different accounts at the same time. You don't want to provision something in one place, something in another place, and then how do you hook these things up? You want to do it in one go. So I'm using Terraform 13 here. So the first thing you do when you like manage these like bigger environments is, or the first thing you have to know about is that you can use multiple providers. So these are all AWS providers, but they've got different aliases, which means they can have different, I can point them to different accounts, different sets of credentials. So in this scenario, I've got a networking, and I've got an account A and account B. I'm actually only using these two, but you can have many of these, like you can have a few. Then in your, like I've just got a main over here, and then I've got a module to spin up a VPC. And into my module, I pass in which provider, and I override the default AWS provider for that module. So modules inherit the provider, like the main provider for Terraform. I just override that, and I say, go and provision this into the networking account. That's basically what that says. Not going into the VPC. Like this is standard stuff, and it's pretty nasty modules I wrote last night. So it's the idea that counts over here. Then now I've got a VPC. I need to share it with someone. So first thing I do is I create, and this is like a bit of a wonky thing within AWS. Like you create a RAM share and you register a AWS resource with the thing you want to share. So in this case, I am sharing, it sits still, the RAM share is coming from my networking account, and I'm sharing the private subnets, those private subnets that don't have access to the, that doesn't have the NAT in them. They've only got a route to the NAT, and they don't have a direct route to the internet. I'm only sharing them out. Then, and all this does, it creates a RAM share and with those resources in it. Then if I actually want to share this out to someone, and there I commented it out, but here you can have this module has it's deploying stuff in a networking account, and it's deploying stuff in the account, the receiver account. And so this provider is pretty interesting, and a lot of people don't know, like this kind of confuses them a little bit. So I like, this is the resource share I want to share. And if I go into this module, modules usually don't have providers. So if you've worked with Terraform, you'll know, like, this is a bit weird. Why is there a provider in here? The reason is it's basically a proxy provider. You'll see it, like, this thing doesn't do anything. It's got an alias, and that's it. So I have to pass this into the module, otherwise it's going to break. What this allows me to do is now in here to say, go do a lookup on, because I need an account ID to do a share, go look up using the receiver. Go get me the receiver's ID. And then I want to associate that ID, which is over here, with this resource share. And this happens within the networking account because that's where that share lives. And if your organization isn't set up correctly, you actually have to go into that sub account, into that receiver account, and accept that share. So there you go. So you're hopping between accounts in your code, but you can totally do this. A transit gateway attachment is actually way more complicated because you're sharing the transit gateway, then you're doing the attachment, and then you're accepting the attachment as well. So you're hopping between these things. And Terraform is really good at maintaining, understanding the dependencies between them, and knowing the order in which it should be done. You can hard code the order as well. So if I'm not happy, like if I'm afraid that this acceptor is going to try accept something that's not, that doesn't exist yet, I can totally do this, where I can say, it depends on the invite being sent. So I can do that. But because this resource is being referenced, Terraform understands that thing first needs to exist before we can do that. So this is how you, like, it's really this simple to share out or to create multi-account resources. And this is sharing. I've got an example of how to create a peering network as well between multiple accounts. And I'll add in a TGW. I think it's interesting to add in a TGW for people to have that as a reference. In a multi-account environment, it's super easy. Like there's a lot of examples how to do it in a single account. What this does look like now is I've got 2 accounts. So I'm using Firefox containers. So in here, I'm in an account. Let's see if this thing is, chances are good. I have to log in again. Nice. This is still running. So I'm using Session Manager. So I've got two EC2s pinging each other. Don't worry about these, what you call it, account IDs. This is a play control tower, so you guys can't. If you can break it, you can get it. So in here we've got EC2s. Okay, let's reload. Yeah, should be good. Yeah, so there we go. So these EC2s live in different accounts. This is a networking account. What this looks like from this account that I'm sharing. So over here I'm in account A. So in the networking account, if I go to RAM, let's see, there's a share in there for the subnets. So shared resources, I'm sharing those 2 subnets out. And over here, if I go in here, you'll see in this VPC, there's a VPC, it doesn't have a name. And I've got subnets without names as well, because that's those tags that don't propagate. What's really cool though, and that's where I said you can reference each other's security groups. Like these EC2s, if you look at its security, this thing is only allowed to ping a security group, and that security group is the security group that sits in this account on this EC2. No, wrong place. Oh yeah, that one. And like I think that's pretty cool. No, like locking it to a CIDR range or wonky stuff like that. It's like this is anything that has the security group attached. I can chat to it, and then in here you can see all your network interfaces. So these are the 2 meetup network interfaces. They sit there, and security groups. I should see the security group. And yeah, okay, it's giving me both because the one is referencing. Okay, this is the actual one, and this is the one that's referencing it. So from a central point of view, I can see all of them, it's pretty nifty. Like from a security point of view, like as a networking guy as well, I like it. I can see everything that's going on in the network from one place. So yeah, that's my story. I hope you guys liked it. I hope at least someone learned something.